there and welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we are simplifying surds. So to start with, I want us to link to a previous idea that we know about multiplication and repeated addition. If we were asked to write the following as a product or a combination of products, i.e. multiplications, how would you write 3 add 3 add 3 add 3 add 3 add 3? Well, you would write it is 6 lots of 3. 6 multiplied by 3, wouldn't you? Now suppose I said, well, what's root 3? Add root 3, add root 3, add root 3, add root 3, add root 3. Hopefully you could see that this is similar idea. This is 6 lots of root 3. And you'll remember in a previous video that I said mathematicians write that just like 6 root 3. They don't bother writing the time sign. Now, how would you write this as a combination of products? Well, you've got a 3 added together 1 time, 2 time, 3 time, 4 time, 5 time. So I would say that is 5 lots of 3. And you've got a 7 added together twice, so that's plus 2 lots of 7. Now what would you do in this case here? It's very similar. You've got yourself root 3, 5 lots of root 3. So that's going to be 5 lots of root 3, which we just write as 5 root 3. And we've got ourselves also 2 lots of root 7. So we've got a root 7 here added to a root 7 here. So it's going to be plus 2 lots of root 7, which we just write as 2 root 7. So that's the first idea I need us to know for our simplifying our surds. The second I'm going to show you by an example. Suppose we were asked to simplify the square root of 18. This is similar to if we're being asked to simplify a fraction like 4 over 8. Whenever you've got a fraction like 4 over 8, you have to simplify it. You have to ask yourself what's the highest common factor of 4 and 8, and you say it's 4, and you divide the top and bottom by that to get it to be a half. Now I told you whenever you have a fraction that needs simplifying, you should, and similarly with surds, whenever you have a surd that needs simplifying, you should also. And it's a slightly different technique to simplifying fractions, but the principle is the same, that you must simplify where you can. What you do is you look at the number underneath the square root sign, 18, and you ask yourself, can you write 18 as a number multiplied by a square number? Can you write it like that? So can you write 18 as two numbers multiplied together, let's say, one number here and another number here, where one of the numbers, let's call it this number, is one of the square numbers? Can you write it in that form? Well, look in your squares. 1 goes into 18, that could be 1 times 18, okay, that's fine. 4, no, 4 doesn't go exactly into 18, if that has to be a whole number. By the way, this here should be a whole number. 9, yes, 9 goes into 18, that's good. 16 doesn't, and 25, etc. too big. So let's choose our number to be 9, and the other number therefore must be 2. And now we can use the law of multiplying surds. The square root of the product is the product of the square root. So I can break that up into the square root of 9 multiplied by the square root of 2. And the square root of 9 is 3, and the square root of 2 is a surd, so that's 3 times root 2, and a mathematician writes 3 times root 2 as just 3 root 2. And that is the simplified version of the square root of 18. So what's the technique? The technique is to try and write whatever's underneath the square root as a product of the biggest square you can find that goes into that and a whole number beside it. Then break up the square root and then simplify. So that's the technique. Let's try it on some questions. Okay, here we go. Let's simplify the following. Root 50, root 99, 3 root 50, 7 root 99. To do this, we need to know our square numbers. Can you recall them? I'm going to have them up here on the side so I can easily refer to them. So let's think of 50 and think what's the biggest square we can think of that goes into 50. 1 does, 4 doesn't, 9 doesn't, 16 doesn't, 25 does, that's pretty big, 36 doesn't, 49 doesn't, and then we're too big. So let's write root 50 like this. Let's write it as root 25 multiplied by 2. Then break that up into root 25 multiplied by root 2, which is going to be 5 times root 2, which we just write 5 root 2. And we're done. What about this one? Let's think of what squares go in. Well, 1 goes into 99, 4 doesn't, 9 does, 16 doesn't, 25 doesn't, 36 doesn't, 49 doesn't, 64, etc. So 9's the best we can get. Always choose the biggest. So we're going to write that as root 9 multiplied by 11, which is root 9 multiplied by, I'm going to start dropping the multiplied by sign, root 11, which is just 3 root 11. And there we go, simplified that one. Now this one here is 3 root 50. We've already done root 50, but I just want to show you it with a number in front of it. So keep the 3 there and split up root 50 just like you did before. Call that root 25 times 2. So that's 3 root 25 root 2. Root 25 is 5. 3 times 5 is 15. So this would be 15 root 2. And that makes sense because it's 3 times root 50. We got that 1 root 50 was 5 root 2. So 3 root 50s must be 15 lots of root 2. And 7 root 99, how would we do that? Keep the 7. Think of the biggest square we can that goes into that, and it would be 9 times 11. So we would say that's 7 root 9 root 11. Root 9 is 3. 7 times 3, 21. And keep your root 11. And there you go. We've simplified those surds. Next example. Find the value of the integer k such that a is some number times root 2. And root 80 is some number times root 5. All that's asking you to do is a weird way of saying simplify root 8 and simplify root 80. So let's get our squares up and let's think to ourselves, can I think of the biggest square that goes into 8? 1 does, 4 does, and then 9 etc. is too big. So let's pick 4. Let's write root 8 as follows. We're going to write root 8 therefore as root 4 times 2, which is going to be root 4 multiplied by root 2, breaking up the square root, which is 2 root 2. So we were asked to write it in that form. We did, and we found that k in our case was 2. What about root 80? Well, let's think of the biggest square we can that goes into 80. 1 does, 4 also does, 9 doesn't, 16 does, 25 doesn't, 36 doesn't, 49 doesn't, etc. So we're going to write root 80 as the square root of 16 multiplied by 5, because 16 multiplied by 5 is 80, and 16 is the biggest square we can think of that is a factor of 80. So we're going to write that as root 16 root 5, and root 16 is 4, so we've got the answer 4 root 5. And we found it in the form requested, where we found k, the number, is 4. So these questions were just basically saying simplify root 8 and root 80, just in a slightly different wording format. Okay, last question now, and the hardest type of question. Sometimes we're asked to simplify a combination of what appears to be surds. How do you do this? First thing you need to know your square numbers. Then what you're going to do is each surd separately, you're going to break that up, and break that up by the technique we've talked about, and then you're going to work it all out and collect like terms. Let's give it a go. That 10 there, just keep it there for now. Now think of the biggest square that you can that goes into 32. I know it's 16, so I'm going to write root 32 as root 16 multiplied by 2. That's the first bit done. Don't forget you've got a takeaway here, and don't forget you've got a 4 here. Now I'm going to write root 18 as the biggest square I can times another number. So 18, I'm going to write that as 9 multiplied by 2. 9 is the biggest square that I know that goes into 18. Don't forget you've got a plus here. Keep that 2. And I'm going to think, what's the biggest square that goes into 50? I know it's 25, so I'm going to write that as root 25 multiplied by 2. Keep the 10 there. That's therefore breaking up that root 16 root 2. Keep the takeaway. Keep the 4 there. That's therefore root 9 root 2. Keep the plus there. Keep the 2, and that's therefore root 25 root 2. Now we can start to work it out. Root 16 is 4. 10 times 4 is 40. So we've got 40 root 2's. Now what are we taking away here? Root 9 is 3, 4 times 3 is 12, so we're taking away 12 root 2's. And lastly, root 25 is 5, 2 times 5 is 10, so we've got add 10 root 2's. Now it's a simple job. 40 root 2's, take away 12 root 2's is 28 root 2's, add back 10 root 2's, we have ourselves 38 root 2, and there you go, we have simplified that surd. And that's it for this video. Thanks for watching.